just both having the same problem. Okay, while I'm waiting to hear back on you, let me go ahead and bring up, because unfortunately this is a new system and I don't have, okay, it's not letting you. Natalie, can you look at the bottom of this Google Meet screen? And can you click on the Present Now button? Oh, yeah. Oh, there we go, Jessica. Thank you so much. Okay, so let's go ahead and go back up to where it says Star Math Student. And I'd like to take a look. So that monitor password should be admin, and that should be a capital ADMIN. And let's see what happens. The monitor password is incorrect. Oh, great. Let's double check. Go ahead and push OK. And then push cancel. Right, let's see this one more time. Let's start from the beginning, hopefully. Okay, and then click I am a student. All right, and then your, sorry, all right, log in. And Jessica, thank you so much for helping us out with this. Okay. All right, and then let's go to Star Math. There you go, Miss Lee. Next. Bringing us back to this. So let's try it this time without caps. Hopefully, maybe it'll do it. So ADMIN with no caps. Oh, well, there we go. I'll make sure to adjust that on the PDF and I'll send it back out.
Yes.
Thank you so much. Gage, you have a question?
Yes. What site were we on where it said Star Math Renaissance? Where is that?
I'll go ahead and show that one more time here. Jessica, thank you so much for sharing your screen with us. And it seems that you guys, Gage, you guys don't have this PDF, so I'm actually going to fix this because this should be a lowercase anyway, and I'll send it to Miss Lee so she could post it for you guys. In order to get to that site that Jessica was at, you first need to go to harlandale.net, click on For Students, and bring up your SSO login. And this is where you log in first. Once you do that, you're going to have a grid of a whole bunch of different applications. You're going to look for Accelerated Reader. Then it's going to open up the Renaissance website, and you pretty much saw the rest of how to get started on there.
I looked up the Google, and it's not letting me in. I don't know which site it is since there's more than one site.
For harlandale.net?
Yes.
Okay, that's just weird. Copy that into here, and then go ahead and click on that link page. And once you click on that link, go to the For Students and single sign-on. And then that's where it's going to take you to that user ID and all that fun stuff over there. And let me, this when I go back to harlandale.net, it says it's blocked.
I can't find For Students.
Oh, you know what? How about, let's see if I can send you this.
Never mind, I found it.
You got it? Okay, good, Gage. Daniela, I don't know. When I go to the Harland, it says it's blocked. Try clicking on the link that I typed into the chat, Daniela, and see if that helps any. That's just weird. But right now, I'm going to update that PDF.
Miss, what do we put in for the the SSSO login thing?
That should be your student ID. And then, let me, there we go. Your password, that one is like a weird collection of your last name and your social security number and your first name. So if you don't know that password right now, I can send it to you after, here we go, sorry, after our notes, and you can get started on that Renaissance quiz. Oh, okay,
I'm already
good.
in.
Thank you so much, Ian. All right. So now you guys see how you can get logged in. It seems like we got past all the hurdles. Okay, good. Thank you so much, Chris. Yeah, we were really scared that if you guys didn't have us here like guiding y'all through it, and even then, look, we ended up seeing that they gave us the wrong info. So I'm glad that we did this together. We just wanted to make sure you guys could log into it yourselves because I believe most people should be able to get it done today, but sorry, just double checking. So Wednesday is going to be the official day that you can take the test. You can start it right now, but I don't want to waste too much time and make sure that we get our notes done. So we just want to go through this, make sure you can log in. And like I said, the actual Renaissance test, we're going to officially assign it for Wednesday. So you have all of Wednesday to have it done, okay? So again, from the home screen, you go to For Students and then highlight Single Sign-On. Or whenever you click on it, you can also find Single Sign-On right here. All right. Like I said, the main purpose of this was just to make sure that you knew how to log in. And I am going to go ahead and update this PDF so that it reflects the correct information. All right. So now that that's out of the way, like I said, I just wanted to go over how to log in. You don't have to start the test right now. Let's get to our notes. And again, I'm just using Cornell notes. So let's begin. So we're going to be solving, all right, here. Solve each of the below for X. That seems kind of, well, obvious. So example number 1. We have 2x plus 4 equals 14. So again, we have 2x plus 4 equals 14. What do you guys feel my first step should be? What do you feel my first step should be to solve for x? Okay, how about this? Who has no idea how to solve for x? Either type me here, what's x, or unmute and say, I don't know.
You have to split them in, split it down the middle. Split,
Ooh,
what do you call it?
Split. What do you mean down the middle?
Put it between the equal sign, the line.
Okay. So that isn't exactly the middle, but okay, so you're telling me split this down the equal sign. Okay, that's a great start, Ian. Then what?
And then you just gotta just leave the 2x alone for right now, and then yeah, do the opposite for the subtract 4 from both sides from the 4 and the 14, and then we'll just pause right there for right now.
Okay, So he said subtract 4 from both sides because it sounds like Ian wants to use the inverse operation. And he knows that, there we go, whatever you do to one side of the equal sign, that's why he wants to visually split it in half. He has to do it equally to the other side. Okay. And what does that leave me with?
The 2x.
Keep going.
And then the 14 and then minus 4, which is the 10. So you have 2x and 10.
Oh, awesome. But what happened here? What's 4 minus 4?
It's 0, so you can just put a line through it.
I'm going to do a big fat 0 because sometimes people think that line is a 1. And just in case, because I've also noticed some people forget that there's an equal sign there. And you said that 14 minus 4 is 10. Okay, that's beautiful. Now what?
Now you gotta, because the 2x, it's multiplying, the 2 is multiplying by the x, so you gotta do the opposite. You gotta divide by 2 on both sides.
Oh, I do have to divide by 2 on both sides. Okay, so I'm going to use my orange here. So why did you choose division? Why not subtraction?
Because you're multiplying the 2x.
You are too smart, Ian. Okay, so your inverse operation is division this time. Okay. Do you guys know what 2 divided by 2 is?
1, so it's x by itself.
Ooh, nicely done, Gage. You are correct. That is left with 1x. Do I have to write the 1 in front of it?
No, just x because it's 1 by itself.
Yeah, so because there is an x already, it's assumed that we have one of them. Okay, so then 1x, don't forget the equal sign because everyone seems to forget it, equals how much?
5.
5. Okay. Now, what I'd like to do, usually I also split my page down the middle, but I want to make sure that we write down these steps on what we had to do. Okay, so this was like a two-stepper, right? So I'm going to say basic steps to solve. And so in pink, there we go. Sorry, didn't mean for it to be all twinkle. That was our first step. And what we did was remove our constant Now, I need to double check with y'all. Who does not know what constant is? Oh, I had a lot of people in chat. So taking a look, who does not know constant? Okay, so constant is a number that it's by itself. It has no variable attached to it. So the way that we remove our constant is if it's positive, we subtract. If it's negative, we add. We're doing the inverse operation. So I'm going to write that over here. Using inverse operation. So that should either be subtraction or an addition. Now, after that, after we remove the constant, we removed the coefficient. So if a constant is a number, like both of these are constants, they're numbers by themselves. What do you think a coefficient is? What do you think a coefficient is? I have no idea what a coefficient is. Who's with me? No clue. Really? Everyone knows, but they're silent? I think that's a lie. And you know what I'm working with. who has no idea what coefficient is. No clue. That's okay. I just need to know if I need to skip over this. The numbers that aren't, you're right that they are the numbers, but these specific coefficients, they're the numbers that are attached to the variables. So in this case, my coefficient, I only had one of them. My only coefficient was 2. Then I had 2 constants because these are numbers that are by themselves. Now, in order to remove the coefficient, again, we're going to use the inverse operation. But this time, we're going to most likely, more often than not, use division. But sometimes we're going to use multiplication, either the dot or parentheses is what we're going to use, okay? Now, in this case, like I said, I'm keeping the colors very specific. I'm going to use pink to remove my constants. I'm usually going to either subtract or add. And then I'm going to remove my coefficient. Most of the time, it's going to be division. Sometimes it's going to be multiplication. But don't worry, we're going to go through these examples. So we're going to use these basic steps for example 2. I have negative 3x minus 7 is equal to 11. So I'm going to take out my pink pen because what should I do?
Remove constant.
Which is the constant I should remove? That is absolutely correct. Ooh, 7. Although, what kind of 7 is it?
Negative.
It is negative. So, because it's negative, what's my inverse operation?
Would it be positive?
All right. So, what should I add 7 to? Be very specific.
11.
Ooh. Anything else? It's an obvious one that I didn't write down. From the negative 7 as well. Thank you so much. Do you guys want me to split it down the middle like Ian had suggested last time? Do you want me to do that again?
Yes.
Okay. Negative 7 plus 7 equals?
Zero.
Big fat 0. All right. Let's bring everything down. What do I write?
Negative 3x and then equals 18.
Ooh, awesome. Okay, so now I take out my orange pen. What do I do?
Divide 18 and negative 3x.
By what? What should both of these be divided by?
Negative
Almost?
3x.
Almost?
Positive.
Further. So what do I want to get rid of?
You're just trying to get rid of the negative 3.
There you go. So don't include the x because if not, that means you're getting rid of everything. You're left with nothing. So because they're being multiplied, I am only dividing by the negative 3. And just like last time, negative 3 divided by negative 3 is?
1. Or, yeah, I don't know.
Final answer time?
Negative 6.
Love it. Oh, you know what? I wasn't boxing my answers. How dare I? Okay. Example 3. Do you guys think we can fly through this because this is super easy?
Yes.
Ooh. Okay. Actually, I don't know. This one looks ugly. This says x over 2 plus 5 equals 1. Oh, function. I have confidence, okay? We got our 2 steps. Boo, we got this. So step number 1 in pink.
removing a constant, so you're gonna have to subtract 5 from both sides.
Okay. Oh, I almost forgot. There we go. Subtract 5 from what and what?
Positive 5 and 1. Positive
Awesome.
1.
Ooh, thank you for being so specific. Again, we have a big fat 0. So what do I bring down?
The x over 2.
The equal sign. That doesn't look
Negative
good.
4.
What was that?
Negative 4.
Okay, good. Thank you very much, Ricardo. I thought I had to bring out my number line again. Okay, now, remember, I told you, the next step, whenever we remove our coefficient, more often than not, it's division. But then I said sometimes we have multiplication.
Yeah,
Now-
you're gonna do multiplication. Oh, my fault.
Well, right now it says x over 2. But what does that over mean? Because, I mean, that's like a English preposition word. What does that mean in math?
Division.
Division. So what's the inverse operation to division?
Multiplication.
So what do you think I should multiply both sides by?
2.
2.
Yeah, absolutely. Because I want to get rid of 2. So I'm going to put parentheses, which mean multiply. I'm going to put 2. Usually I like to put it in front, but I don't have the space here. So I'm going to put this one here. Now, remember, oh, wait, no, I'm getting my classes confused. If I wanted to turn this orange 2 into a fraction, how could you do that for me? How could you turn 2 into a fraction? Not a trick question. It's a ridiculously easy one. So if you're thinking, no.
You put it in front of the fraction?
So if I wanted to turn 2 into a fraction, because right now this is a whole number. Like, don't even worry about all this junk here. How do I turn this number 2, a whole number, into a fraction?
Put it over 1.
Yes, thank you very much. And I also see, I'm sorry, Abigail, I just saw it in the chat. Put it over 1. Isn't that still equal to 2?
Yes.
Now, the main reason I wanted to do that is because now we have the situation all over again. So what's 2 over 2? Two over
4.
2?
Like 0?
1.
By itself? I don't know, because there's
1.
even like
It's 1.
1.
One.
Yes.
One.
I hear someone saying 1.
one.
Yes. Now what we've done is we've made this exact same situation up here. I'm going to put a giant 1. So in that case, what am I left with? I know it looks a little messy.
2 times
What's that
-4.
equal to?
X and negative 4.
X
X.
equals -4 times 2. Times 2?
Negative 8. My fault.
Oh, no, that's all right. That's all right. Now,
-8.
in all technicality, this 1 is still here, but just like over here, did I have to write 1 in front? No. Do I have to say x divided by 1? No, just like I didn't have to say 2 over 1 equals 2. You don't need to put the over 1 here. You just need to understand that whenever you multiply 2 and you're also being divided by 2, that it does reduce to 1. So yes, we are just left with x equals -8. Okay, so that one, it took a little bit longer because we thought we had the F word, fraction, but we didn't. So let's try example 4. Example 4 is x over 5. I think this one we could probably move a little bit quicker. Minus 1 is equal to 2. So first step in pink, what do I do? There you go. First step in pink.
Add both sides by 1.
Oh, yes. And I'm going to stop playing super stupid, and I'll do exactly what you asked. Although, what's negative 1 plus 1? That's all right, Jessica. Sorry?
Oh, it cancels out. It
Time.
cancels out.
Oh, girl. I thought we were tight. Not the C word. Never the C word. I hate the C word. So can you tell me what negative 1 plus 1 is actually equal to without using the C word?
Zero.
Thank you very much. 0. Big fat 0. Because like I said, that C word, you can confuse a 0 and a 1 really quickly with the C word. That's why I hate the C word. Okay, let's bring it on down. X over 5 equals 3. Thank you very much. Okay, orange step. Orange, you glad it's orange?
You have to multiply them.
Multiply them both by
5.
5. Perfect. Why did you choose 5?
Because x has to be by itself, and 5 can help it reduce.
5.
Okay, so we want to get x by itself. There's a 5 with it, and it's being divided. So the inverse operation is multiply. So I'm going to squeeze that 5 in front. There we go. So what happens here? 5 times x over 5. What happens? What happens with the 5 divided by 5? Awesome. It is a 1. Ooh, you guys on fire. So final answer time?
Equals
X
15.
equals 15.
Yes. Okay. I don't think I'm going to be able to fit that last question here. So I think I'm going to put it over here, number. Oh dear. Oh dear. Oh no, I got marker all over me. This is number 5. And number 5 has an extra step. It says 2 parentheses x plus 1, close it, equals 20. Function. There's an extra step now that I have to do that I didn't have to do before. What do those parentheses mean? We were kind of doing this like all last week.
Order of operations. You got to do the parentheses first.
The order of operations says that you do whatever's inside the parentheses.
PEMDAS?
Times 1.
It's PEMDAS, right, miss?
Well, yes and no. Because tell me, inside the parentheses, it says x plus 1. Is there anything you can do to x
No.
plus 1 right now?
No.
No. So there's another word that we were using last time.
Multiply.
These parentheses.
Distribute.
Distribute. Yes, ma'am. So I'm going to try and squeeze this in here. Because if you have parentheses, you must, let me see here, distribute. There we go. Distribute if you have parentheses. So I do have parentheses. What's in front of them?
A 2.
So what am I going to do with this 2?
2 times x times 1.
Ooh, 2 times x and also times 1. Okay, what does that give me?
2x. Plus
2x.
And then what?
Plus 2.
Plus
I mean,
2.
plus 3.
No, you were
Wait,
correct. You are
yeah.
multiplying. You're good, Diamond. Equals 20. So now this looks like what we had before. So, pink step, what do I do?
Do you subtract the 2?
Now I see it subtract 2 from both sides. And what's 2 minus 2? Say it correctly.
0.
Awesome. Big fat 0. It eliminates. What am I left with?
2x.
Uh-huh.
18.
Equals 18. Orange step. Orange step.
Do you divide the 2?
Yeah, you divide both of them by 2. You're absolutely correct, Sophia. What happens here? Ooh, Chris is already ahead of us. Awesome. So
1.
Chris was left. Okay, yes, thank you very much, Desiree. That reduces to 1, and that's how you are left with x equals 9. Now, you guys have 3 examples to do on your own. Number 6 says 4x plus 5 equals 21. Number 7 is x over 3 minus 1 equals 0. And then number 8 is 3 parentheses x minus 2 equals 15. Now I'm going to flip on over. These 3 are for you to do on your own because I know I only have enough time to maybe do one more problem with y'all. So flipping on over. And we have example number 9. Now this one is really weird looking. It's A plus B equals C. And it says solve for A. I'm gonna get a little bit of color here because this is strange. So I want to get A alone. If it says A plus B equals C, how do I get A alone? Is A alone? Is A alone? Uh-huh or uh-uh?
Yes.
Is it alone on this side of the equal sign?
It has B.
It does have B with it, Sophia. How do I get rid of that B?
You subtract.
Yeah. So B minus B equals
0.
0. And I'm going to put it here as well, but I'm going to put it off to the side because remember how we had our apple plus apple equals 2 apples? Well, here I have a cantaloupe and a banana. Not the same thing, so I'm not going to put them right under each other. So now I have A equals, I have a cantaloupe minus banana. That's not too bad. I'm going to try one last example because I know you guys need to get on to your next class. This one says D, E, equals F. Solve for E. Now, what do you think is happening between this D and E? Mathematically, what's happening? Add, subtract,
They're
multiply.
multiplying.
Oh, they are multiplying. Okay, so if they're being multiplied, how do I get rid of, or how do I get E alone?
Divide.
Divide.
Divide both sides by? What do I want to get rid of?
E.
Well, actually,
D.
I want to get E alone. So what do I
D.
divide by?
D.
Oh, I think you mean D?
Yes.
Because we had B on the last one.
D.
Yes, D is in dog. And D divided by D, you guys know this answer.
0.
Oh? Just like 2 divided by 2, negative 3 divided by negative 3, D divided by D
Okay.
is
1.
1. And Abigail, you are correct because I'm left with just one E. So I would say E equals F divided by D. Now, I understand that we are out of time. I see some of you guys are leaving, and I do need to get to my geometry class. We did have, I believe, 2 more problems, number 11 and 12, to do together. So I'll go ahead and just like last time, I'll finish making that video, and I'll have Miss Lee upload that as well as the PDF. All right. But thank you guys so much for helping me out trying to figure out that Renaissance. That you will be assigned tomorrow. All right. So don't forget to do your exit ticket. Hasta luego. All right, just wanted to finish off the last few problems together. So we had just done number 10. So let's continue with example 11, which is G minus H is equal to I. And this time it's asking us to solve for G. So I'm going to grab my highlighter again, and G is the variable that I'm trying to get alone this time. Now, G is not alone on this side of the equal sign. It has H being subtracted. So, since there's subtraction, then my inverse operation should be addition. I want to remove that H. So I'm going to get my pink pen, and I'm going to add H to both sides. Now, negative H plus H is a big fat 0, leaving us with G. And then our equal sign. Now, remember, just like I had said over here, in this case here, we had a cantaloupe and a banana. They are not the same fruit, so we are not going to combine them. Well, here I have, I don't know, an icicle and a hot glue gun. That definitely shouldn't mix. I know, I'm really reaching here. So I'm going to put my I and then plus H. There we go. Now, do know that your commutative property of addition would say that I could switch those around if I wanted to. I could say G is also equal to H, plus I, and that is the same. Now here, commutative property does not work with subtraction. I can't say that C minus B, cantaloupe minus banana, is the same as banana minus cantaloupe. So the only one that you can switch around would be addition or multiplication. Last example, example 12. Example 12 says J over K is equal to L. And it wants us to, of course, solve for J. So I'm going to grab my highlighter because I want to know which one I want to get alone. Now, number 12 is actually very similar to number 3 or 4 that we had done on the front side. So here we said whenever we had our variable divided by a number, just like what we have here, this is just a one-stepper. So since J is being divided by something, I want to get that something away from it, the inverse operation to division is multiplication. And I don't want to forget to split it down the middle. So since I'm dividing by k, the opposite would be multiplying by k. Remember, k over k reduces to 1. So I'm just left with j equals, well, I could just leave it like that. KL or LK. It doesn't matter the order for multiplication. There you go. And if you wanted, you could put a dot to show that it's being multiplied, or you could even leave the parentheses as well. Now, nonetheless, J is equal to KL is the same as saying J is equal to K times L. J is equal to K times L. All of these are all equivalent. Sorry, I went to more and more cursive as I continue to write. But all of these mean the exact same thing, all right? And you could even flip them as well, but that's just a lot. So you guys have 4 problems left to practice. You have number 13, m minus n is equal to O. And this one it's asking you to solve for m. So if you don't want to write it all, you can just highlight the variable that you're solving for. Number 14 is p over q is equal to r. Number 15 is s plus t. Make sure the plus and the t will look very similar. Put a little tail on your t. Just so that you know which one is a plus and which one is a variable, equals u. And again, we are solving for s. And lastly, number 16, vw is equal to x. Now remember, since there's nothing in between the v and the w, it's assumed to be multiplication. All right, so you guys have your 4 problems here. Your 3 problems on the front, and